Welcome you all. I am Aldous Exley from the Department of EEE, Frame College of Engineering and Technology. So let us discuss about the basic principle and construction of transformer. So transformer is a static electrical device. It's a very essential static electrical device in power system. Without transformer, we can't transmit as well as distribute electrical energy. So this block diagram helps to understand what are the why transformer is very much essential in power system. So you see, in generating station, the electrical energy is produced in 11 kV only. This 11 kV volt cannot transmit for long distance. Normally, the generating stations are constructed far away from human living places. So we have to transmit the electrical power produced in the power station for long distance because cities are far away from the generating stations. So we have to transmit the electrical energy which is produced in the power station to long distance. For that, initially the low voltage, normally 11 kV volt produced in the generating stations are stepped up using one power transformer. This power transformer is constructed in a substation called step up transmitting substations. In the transmitting substations, the 11 kV voltage is stepped up to 440 kV. Then the 440 kV AC supply is transmitted through towers for long distance. Then in the receiving side, in the city side, in the human living places side, another one substation is there. That substation is called distribution substation. In the distribution substation, another one power transformer is constructed. That power transformer reduced this voltage, that is 440 kV into 11 kV. This 11 kV voltage is again circulated through all the distribution transformers which are constructed in the roadside. So in this way, power is produced, transmitted as well as distributed. In all the places, transformers are very much essential. So without transformer, we can't transmit as well as distribute electrical power. So let us see the working principle as well as construction in detail. So transformer is a static electrical device. It has no moving parts, so that it is called a static electrical device. Then it can transform electrical energy from one alternating current circuit to another one through magnetic field. In a transformer, two alternating circuit windings are there. These two circuit windings are electrically not connected, but these two windings are connected via magnetic field. Then by using this transformer, we can modify voltage as well as current, but we can't change the frequency. So the very important basic parts of a transformer or magnetic core as well as winding. Core is nothing but frame. You can see in the image. So it actually it is used to provide mechanical support to the windings used in transformer. Also, it has to provide easiest path for flux lines. Normally, the core is in square or rectangular in shape. The vertical portion of the core is nothing but limb, as well as horizontal portion of the core is called yoke. So in the image, there are two outer limbs and two um, yokes are there. One is in the upper side, another one is lower side. Normally, this core is fabricated using high-grade silicon steel. Why high-grade silicon steel is used? Silicon steel is used is to minimize one magnetic loss occurs in the core called hysteresis loss. Also, the core is not a solid piece. It is made up of several number of thin core pieces. So these thin pieces are called laminations. Several number of silicon steel laminations are joined together to make a core. So the laminated core helps to minimize another loss called eddy current loss. The thickness of each lamination varies from zero point 0.3 to zero point 0.5 mm. The thickness is dependent upon the rating of the transformer. Then important part is called winding, transformer winding. Normally concentric winding is used in core type transformer, as well as sandwich winding is commonly used in shell type transformer. Then, based on the core transformers are classified into three types: core type, shell type, and berry type. So this image shows core type single phase transformer. In this core type, winding surrounds the core. Also, through the core, only one magnetic circuit is completed. It has two limbs. The core has two limbs and two yokes. Normally, these core type transformers are used for high current applications because natural cooling is more effective. Then shell type transformer. In shell type transformer, the core surrounds the winding. Then here two magnetic circuits are there. Then the core has two vertical portions, that is two limbs and two yokes. Normally this type of shell type transformers are preferred for low current high voltage applications because natural cooling is not possible here. Then berry type transformer. This berry type transformer look like spoke of a wheel of a two-wheeler. Here more than two magnetic circuits are possible. Next very important protective device is called conservator. Conservator is nothing but one small tank mounted over the main tank. It is used to take off the expansion of transformer oil during fault. During faulty time, the transformer oil is overheated and the oil is expanded. In that time, the expansion of the oil has to be the expand the we have to minimize the pressure produced inside the transformer. For that purpose, we are using conservator. This conservator and the main tanks are connected through a small pipe. Next, breather. It is also one protective device used in transformer. It is acting as nose of human being. The air inside the transformer has to be dust as well as moisture free. For that purpose, we are using breather. It is acting as filter, so it prevents the entry of moisture inside the transformer tank. Normally, it is filled with um, uh, calcium chloride or silica gel. The given image has two breathers over there. One is in blue color, another one is in pink color. Normally, before absorbing moisture, the silica gel look like blue in color. After absorbing, it is in pink color. Then Buchholz relay. It is one gas operated relay. This relay is mounted in the conservator tank. It is mounted in between conservator tank and the main tank. For minor fault, it gives alarm signal. For major fault, it disconnects the transformer from the supply. So it is also very important protective device used in power transformers. Then bushings. Bushings are used to take off the connections from the transformer winding. Normally it is made up of porcelain. It is mounted on the transformer tank. Up to 33 kV porcelain insulators are used. Above 33 kV oil filled porcelain insulators are used as bushings. Then transformer oil. The core winding assembly is immersed in a transformer oil. It is acting as insulating medium. Also, it to protect the core and winding assembly from dirt and moisture deposition. Then cooling tubes. It is provided on the side of the transformer tank. Some of the transformers, instead of cooling tubes, cooling fins are also provided. This helps to increase the heat dissipation surface so that natural cooling is more effective. Then temperature gauge. It is used to monitor the temperature of a transformer. Normally, thermometers are used as temperature gauge. The thermometer is dipped in the transformer oil to monitor the temperature. Then classifications according to the construction of core. Transformers are classified into three types: shell type, core type, and berry type. Now let us compare core type as well as shell type. In core type transformer, winding surrounds the core, but in shell type, core surrounds the winding. In core type transformer, cylindrical type coils are used. In shell type, disc type or sandwich coils are used. Core type natural cooling is more effective. That is why this core type transformer is suitable for high current applications. In shell type, natural cooling is not more effective. Then in core type transformer, single magnetic circuit is there, but in shell type, double magnetic circuit. In core type transformer, core has two limbs. Shell type, core has three limbs. So these are the some comparisons. So now let us conclude this class. Thank you.